You're live. Pause. I want this concurrent viewer to... There's always one guy watching. That guy is me. Oh. It's a real... Wait. What? What's going on? Okay, there we go. I was gonna say, it's me. But for like 20 seconds, it always shows me being live, and I'm like... Okay. So, we'll continue what we were working on the other day. We're learning Clojure and doing it slow and steady here. I found something very interesting. Tomorrow I'll share on the stream on Twitch, and it'll be the what's it called? I'll share it on Twitch tomorrow. When I'm reading the Bible, we'll do like a quick bit about something I found a C.S. Lewis. What do they call that? It's not a deposition. Is it a deposition? No. It's not? No. When you... No. How do you... Speech. Locution, palaver, parlance, prattle, pronunciation. What is this called? Give speech. Pitch, speak, discourse, persuade. Sermon. Sermon, spiel, sermon. A sermon synonym. Alright, so there's a sermon written by C.S. Lewis that I found. I thought it was pretty good. How do you... Written... No letter, no paragraph. What do you call that? Written... Letter. We'll call it synonym. Aha! Okay. Dispatch, epistle, memo, memorandum. Stole, no. Acclamation, no. Fancy word for writing. Write down. Transcribe, chronicle, minute, a minute, and register, enter, inscribe, chalk up, notch, score. No, I'm looking for not a letter. What a thesis, like a thesis. Thesis synonym. That's what I'm looking for here. Aha. Long essay. Dissertation. That's what I'm looking for. Not deposition, but dissertation. Aha. An essay, a thesis, a paper, a composition. These are the words I'm looking for. For some reason, all those words are just out of my mind. I couldn't think of any of them. An essay, a thesis, a treatise, a paper, a study, a composition. Right. I need these words, man. Discourse, disquisition. That's what I'm thinking. Not deposit. Disquisition. Or discourse. Right. There's a discourse, an exposition, or a assessment, appraisal, criticism, discussion. A disquisition. Yes. So I was listening to an audio version of a disquisition by a one C.S. Lewis on the subject of sexual morality. And I thought, that is a thing to share, because it's quite good. It's quite good. Let me, oh. Whoa. What is that? It's got like a chart. Anyway, okay. So, yes, Disquisition by C.S. Lewis. That was quite good. I was impressed about sexual morality. I would share that. I think I should share that on stream later. So product digits, easy math sequences. Write a function which multiplies two numbers and returns the result as a sequence of its digits. All right. So two numbers, A and B. I'm going to multiply these two. You know what I want actually? Product digit. AB. Have a let inside here, which will have, okay, and we're going to say digits function. I kind of want to write this in my editor because it's kind of awkward doing this, but okay, we'll just do it this way for now. So we're going to use recur, and we're going to say if 0, then simply return 0. See, that's a tricky thing. I don't know, maybe I should use a loop for this, because actually it should be like this. It should be something like this. Let's say remainder, or I don't know what we should call this. There's a quotient in the modulus. Call it Q. Quotient of x and 10, and then there's the modulus of x and 10. And I want to say that if you want to return m when the quotient is 0. That's pretty much what you want. It's got to be kind of careful here because you can't just check 0 for x, because you're going to end up with an extra 0 digit. It's like a tiny little small nuance here. And you want to return on Q. Function digits let, not just recur, but conjoin. Oh, maybe I should use a reduce for this. Could do that. Maybe that's better. Yeah. Alright, I'll make this a reduce instead of using a recurrence. Okay. No, you can't use a reduction because the reduction doesn't have a. Oh, you know what you can do though? Reduced. forgot that's there. Should use that. Suppose you want to short circuit a sum. Yeah, that's actually exactly what I want to do. Returns the sum of the integers if less than 100. Reduced big. Keyword big otherwise. Change the range here. Value returned by reduced big short circuits the reduction so that it returns the wrapped value without ranging over the entire sequence. This is useful for infinite lazy sequences. Oh. Otherwise not terminate. So reduced terminates. Okay, that's what we want. Yeah, that's exactly what we want. So, how do we do this? Well, you could just range. I don't really care, actually. And so there's this value, and this is what you're going to destructure each step. And then you say let Q be this quotient of x, M be modulo x. If the quotient is 0, then you want a reduced. No. Well, yeah, I mean, that's when you stop. Yeah, actually, you can even go further and say like ret x is going to be cons ret with m, no matter what, right? You're always going to do that, and then you're also going to have the new value, which is the quotient here. Right, and if it's 0, then you're reduced. Ret Q. Don't really care about the Q anymore. Otherwise, it's just ret Q. Now, I don't know if this works. I have no idea what this is going to do. But it'd be cool if this works. This is why we're doing these problems, to learn. Wow, your coding format is really impressive. Hello, welcome. Hope your day's going well. Welcome. It's impressive, my coding format. Thanks, thank you, I think. It's kind of you to say. And forgive me, I'm a little, I've gotten in the past, I've had folks, let's just say, be kind of critical of my programming. So I'm kind of like uncertain if someone gives me a compliment. So forgive me for that. Hello. Let me, you know what I'm going to do? I'm going to move this because I want to test in an environment here. Ooh, oops. Oh no. Oh. Okay. I have this poor habit of, like, instead of doing this, I'll click here to try to pull it down. But as you see, there's this. If I click that, oh, okay, not a big deal. But so what I'm looking for is there's this let. This should be inside. There's this if range. Not the let. That's the reduce. So actually, the let is in here, and then the range is here. and then you want to have your reduce over here. It's a little kind of funky looking. I probably want, you could do it this way. This is a little easier to read in terms of readability. And then you can take your let out and then take the function out, right? And now the range is clearly associated with the reduction, right? And then you also need an initial state. Yeah, see, that's the tricky thing I have. Kind of a tricky thing with Clojure is that you end up, you know, it's like more verbose doing it this way. You know, it's like really a lot of space and all that, and it's kind of like a lot of, I guess, real estate for your code, but it's a lot easier to see what's happening. Yeah, and then so that way you don't make syntactic errors. And then what you want to do is message retracted. Oof. How do I show this message? Oh man, it's one of the things I don't like about YouTube is it doesn't allow me to shoot. How do I show the message? I don't know how to, oh, okay, hold on, we'll look this up. YouTube chat show retracted messages. Every line is nice. I don't know what's going on. Nightbot. How do I? No. Messages. Hold. Okay, I guess I have to sign into my account. Comment management. Can I do this? Hopefully I don't leak anything I shouldn't be leaking here. Why not collapse all the closed parentheses at the tail? YouTube messages kind of slow. The reason I don't do the collapsing is and that's fair. I mean, some people do that. The reason I don't do that is because I often will edit the code, like as you saw, like I won't finish the whole part of the function, and then I'll get kind of lost as to like where, like in other words, if I was looking at this, like so here I know I need a function, I need a starting point, I need a collection, right? And am I missing something in between? I think that's everything I need for the reduce. What I could have, the problem I could have is maybe like I don't have the range in there yet. Like I'm not sure what I want to put for the collection it iterates over. So then I'd have to actually figure out which one of these opening and closing parentheses that I should put it in. Because if they're all kind of stacked on top of each other, like I'll just show you what it would look like. They're all kind of stacked on top of each other. Like this, and then let's say this isn't here, this is gone. I really like, now I can see it, I guess. I mean, I guess in this case it's not so bad, but if this is like nested in something else, then it'd be kind of have to like figure out which one of these parentheses I have to put it next to, which is just kind of, I don't know. I don't prefer it. I don't prefer it. We'll say it's not really. It's really just a preference. I think YouTube message is kind of slow. It's yeah. I don't think it's. I think it's that much better to do it the way that I do it, but I kind of just prefer it. Automated filters. Okay, I want to turn this off. Allow all comments. Hold, no, what? So maybe if it's potentially inappropriate, I can review it instead of just being immediately rejected. Once you've enabled hold review, you can hide or show messages that YouTube holds. If you select show, time there to hide. You know, it's funny sometimes, like, when you add features to stuff, like explaining it to a user, like what it'll actually do, is very confusing. Like, there's a certain problem with software that I've run into repeatedly, which is like, quote unquote, managing expectations. And it's basically like, it's not really necessarily a bug in the program, it's just the program operates in a way that you didn't expect because your expectations were not set appropriately. And sometimes just plain old like instructions, like what it's supposed to do, how it's supposed to work, doesn't really, there's like a certain friction between the user and what's explained. Point being, I'm looking at this and let me explain what I'm trying to get at here. I'm looking at this messages here and saying, I'm thinking, don't filter my messages, right? Like I want to click this and say don't filter my messages. But what it seems to be doing is, if I don't click this, then it's not going to hold messages to be reviewed, which could mean that actually it's just going to drop those messages. So I don't even have the opportunity to see the messages. Whereas I would like this to mean, click this button and you don't have to worry about your messages being filtered. So I actually think I need to have this on so that messages that would otherwise be filtered are held for me, and then I can okay them, and then they're not filtered. I think that's how it ends up working, which is really weird. Like, that's not at all what I would expect. I would expect that I would turn this off, and then I could just filtering is fine. It's sort of quote unquote managing expectations. And I run into that continuously at my job, where, you know, people have certain expectations for what the software does, and sometimes there's certain open for interpretation, I guess. But it can get kind of confusing. What the user wants and what the software actually does are not always like perfectly aligned. You've got to kind of massage that. Hide chat messages remain hidden from viewers. If take no action, chat messages remain hidden. Yeah, so I don't know what this is going to do. Yeah, okay. Alright, we'll enable that. Try that out. See what happens. Okay, back to what we were doing. So, chat line being redacted. Yeah, we got that. Alright, go back to the chat. Can I have something like a VS Code par info plugin and recognize the code structure by indentation? Yeah, there is a thing a VS Code has. It does have like Calva exists. There's some stuff, although I don't really use it. I'm not sure if I want to use it. I'm kind of conflicted because the problem that I have is, where's Calva? Somewhere here. So I have this, and it does a lot of stuff. Somewhere in here is I guess it'd be syntax or linting. Yeah, linting. I forget exactly what linting does, but code formatting, that's what I'm looking for. Yeah. So there's the style guide. It does this formatting and auto indenting. It does stuff, but I forget. There was some reason why I was struggling to get Calva to work correctly. I think the reason was I needed to get pre-compiled binaries somewhere, and I didn't want to do that. I don't remember. There was some reason why I stopped using it. Maybe I should be using it. Maybe I should go, one of these days go back and try it again. But there was something that was bothering me, and then also I think the indentation too is irritating because what was it? I had like automatic indenting on. It would try to figure out what indenting I'm using, and then it would assume like two smaller indents than I wanted, and I don't know. I let it be for a while, but yeah, I feel that though. I understand where you're coming from. Maybe I should use something special. But I kind of like the idea of like being able to understand your code without, you know, using like extra. Well, I shouldn't say extra. I don't know. That's maybe kind of a silly thing because it's like, well, you're working with something that's highly technical in the first place, so like you're gonna need tools. So saying like, oh, I should have as few tools as possible is like, I mean, yeah, yes and no. I don't know. I think tools that help are probably good. It's its own sort of meta discussion in and of itself, how much tooling you should actually permit. But anyway, Calva's an IDE like stuff, but PAR-INFER only deals with parentheses. I don't know that much is right. Oh, only deals with parentheses. Oh, okay. Yeah, there's probably a PAR. I bet you there's a PAR-INFER in here. Let's see if there is one. There's probably one. Someone probably made one. Yeah, there we go. What does this do? Okay. Oh, yep, it's Clojure. So what does it do though? Does it explain? Oh, I think I know. Oh, okay, I get it. So it'll move parentheses around. Or, wait, I gotta watch it closely. Does something, I understand it does something with parentheses, but what does it do exactly? So what does he do? Trying to follow. There's got to be like a starting point, right? Oh, I see. Okay, so it looks like depending on where the indentation is, that's where it'll move the parentheses. So if yeah, okay. Is that right? How does it do that? Yeah, formatting is kind of a big deal. I probably could use a PAR-INFER. I'll leave it for a while though. There's also something about Clojure that I found kind of interesting. Is there's so many like different ways to set up your environment that you can get kind of bogged down in like just figuring out how you want to set up your environment. So I'll just leave it for now. But appreciate that such a thing exists, and say thank you. Appreciate the suggestion also. But for now, we'll keep it as it is. Can control the indentation. PAR-INFER helps you with the parentheses. Maybe you will like it. It's really cool. Yeah. Let me try it like another time. Let me try it another time. Let me say I appreciate the suggestion. Not a bad idea. Probably. We'll see. But for now, try it another time. I wonder. Because here's another sort of like meta question. Like, if you use like a PAR-INFER, right? You use that program PAR-INFER, or you use something that I guess formats your code automatically and makes it kind of nice. I wonder. Well, actually, I don't know. I mean, I don't know. Now I'm kind of going all over the place because I'm thinking of like style guides, right? Like, maybe I should just research style guides. Actually, maybe that's what I should do. Because the conflict I'm thinking of is like, let's say you write your code with a certain format, certain style, right? And obviously, like, one of the top priorities for your styling and formatting is that you want your code to be readable. Right? Maintainability of your code is extremely important, and how easy it is to understand, easy to read. I would want to optimize for that, like prioritize on that. And I guess you could argue that a tool probably will only help you conform to a certain styling and format, and that whether or not you use a tool is kind of a orthogonal question. So then I guess my question has nothing to do with the tooling. It's more to do with just like maybe the style that I have. But the thing that you end up with is I would use the tool to improve my styling and format, because without the tool, then I've got to come up with a styling format that works, that's sort of doesn't require a tool to write it and work with it. Whereas if I was using a tool, I could use maybe a different style, different format. That makes sense. I don't know. Anyway, all right. Let's not spend too much time on this. But it is sort of like a worthwhile thing to think about, especially because like the reason I'm doing all these problems is like I'm trying to learn Clojure, and it's like, well, that is part of learning the language. It's like, how should you structure your code such that it's readable and understandable and all of that. It's a pretty significant thing as well, because most of code is not. Most of the time, it's being reread by somebody else, and sort of someone inherits it. It's got to read it and understand it, and continue working with it. Also, let me read chat. Doing it right. Focus on one problem. Yeah, it makes sense. Thank you. Thanks. I think I'm not sure if I should be saying thank you when someone agrees with me. It's like I appreciate that. Okay, so let's continue. So I think later I'll take a look at like guides, like styling, different styles of Clojure styling guides. So what I think is right. So we just want digits, and we want to use reduced. And what I want to say is, you take. So you're gonna have this destructured return with an x, and you want to say quote x divided by 10 mod x by 10. This will be the next digit. Then you're going to destructure to conjoin. You're always going to conjoin. Always. So q is right the result of dividing by 10. That's sort of the next step. And you say, okay, if your next step is 0, then you're going to terminate there and add the digit now. This already, right, we've already added the digit, so we kind of, this is sort of already decided this return here. Now I said x and q, these become kind of interchangeable, I suppose. Oh, I shouldn't use x, I should use like just, I guess this is just ret then. I don't really need this. Thinking about it, I think I did that wrong. Let me also go back here. So q m ret, and if q is 0, and this doesn't really, we don't really care about this part. We only care about the first portion. So I have this ret, this function, and we'll start with an empty initial point. Oh, this needs to be, yes, yeah, it needs to be like this. Oh, interesting. Okay, we do want this to be a function, so it's actually going to have two functions inside. We can. I like doing this. I've seen this. Other people do this. Okay. Oops. A little more organized, I think, this way. So you can do your reduce here. And actually it becomes a lot simpler, this part. Alright. And okay. And this will say, you know, some x, doesn't really matter. And then starting point x, right? That's what we wanted to do. So now you can say, refer to this reduction function. And I think that's it. Oh, you need one more piece. That's why you want to split this into two pieces, right? Because it gets a little unwieldy if you put this whole thing inside here, right? So you got this digits function, you got this reduction, and then what you want to do is say to get prod digits, it's will be as simple as a call to, you got this a times b, and then you want to get the digits, and I think that's all you need, and then you're in good shape. And for the testing environment, I'll put this into the what do they call that, into the namespace, quote unquote, pollute the namespace here, and then we can run some test cases, the ones that they gave us. We use these. Why not? I mean, we could write our own too, but that's fine. Just grab these manually. That's okay. Yeah, maybe I think after the 100th problem, I'll take a look at the you know what I should have done actually. I should do this. Print line. Do it this way. And or even oh, that doesn't really work, does it? You know what you can do? I think this is better. Prod digits. Print line. Maybe some kind of regex to do this would be better, but you could do one of these. Doesn't really solve the problem, but it's okay, I guess. Doesn't really save you much. Okay, so now we have because it doesn't really deal with the opening parentheses. You kind of need like, you could technically do this with the regex using like a what do they call that? A back. I don't know if the replace uses regexes though. I don't think it does. Does it? Yeah, use regex. Oh, you can. Okay, so you could use the regex, but you would use a, what do they call that? A back. Well, let me see. Java regex pattern. There's a specification for the regex pattern, which yeah, here it is. What's it called? Back reference. Yeah, you could use a back reference, I guess, to put the parentheses in there to sort of manipulate like more than just replacing the portion you want to replace. You use a back reference to match sort of the surrounding scope, surrounding text. Yeah, I like that. Haven't quite figured out how to like really quickly manipulate using the replace using regexes to like add stuff to the text quickly, but in theory you can come up with some clever things and do things sort of really quickly. But I have a strong brain. I cannot write such long code without run a few times. Do you have something in mind? Force yourself to pass the test by run only once. Yeah. Well, this one is you know, because it's broken up into pieces. It's a lot easier to manage. Like that's kind of how I typically program. I do have to run this a few times though. Like I'm about to run it now before I even submit it. So we'll see problems. But typically, the way I handle it, and I appreciate the compliment. Thank you. It depends on what it is. Like so. I think the styling matters a lot, because if you can appropriately break up the problem into pieces, and then you understand how it's broken, and then you understand the syntax of those pieces, then because it's broken up into pieces, you just have to make sure that the syntax for each piece is correct, right? So that's practice more than anything else. So as an example, like I haven't used this reduced very much, so I might have the syntax wrong here. I could also have some issues of like, maybe I didn't translate this correctly here, the reducer. Like it's kind of, I don't want to say it's arbitrary, but it's basically you're trying to split the problem into logical semantic pieces, not the problem, but the code that you're writing into pieces, right? Because there's sort of two problems you're solving, right? So one problem is there's the actual problem that you want to solve, right? Some algorithm to solve it that you have in your mind, and then there's writing the code that, like, once you've got the algorithm in your mind, then writing the code that actually performs that algorithm, right? Those are actually two separate problems. And that's sort of one of the reasons why you always need tests, is because maybe the algorithm is like, you proved it in your mind, you've got a formal proof of the correctness of the algorithm, but you don't necessarily have any way to know that what you typed into the computer is going to actually perform the algorithm that you came up with, right? Because you could have syntax errors, you could have just things that are sort of not quite exactly what you were thinking, which is sort of an interesting problem in and of itself. But one way to make that sort of increase the odds that what you're thinking of writing and what you actually wrote conform, like they match, is, well, obviously running and writing tests and kind of just iterating over and over. That's one approach, but better than that is like how you structure your code, like really understanding what your code is doing. Part of that comes from experience, just using the language, hence why we're doing these problems, because I want to learn Clojure to be proficient. And the syntax, you kind of just know it. You kind of just know the syntax. Oh, let me put another hour on this. I said I was only going to stream for about an hour, but let me do another hour because I'm enjoying this. I guess eat lunch a little bit later. Or so splitting it into smaller pieces that are digestible, and then also being able to organize it in a way in your mind where you sort of know, or can be confident that each piece is correct, and then the connections between those pieces are correct. But a lot of that comes with experience, which obviously I don't have a lot of Clojure experience. So, but you can also use the structuring of the code itself to really like organize, the pieces. So as you can see, this has like a very clear structure where there's an outer digits function, which is going to take a number, and the intention is to return the what do they call that? A vector of each digit, right? And the way that I intend to perform that is I'm going to perform a reduction, or iterate over perform a reduction and iterate over technically an infinite sequence. Perform this reduction, that's going to return a vector with two values, right? And I'm going to take the first value. That'll be the what I want. And then that breaks down into subproblems, right? Like, okay, well, what does a reduction look like, right? And then that's its own thing. And then how are we going to get the first part of that return, right? It's like, okay, we can use the first function on this return value of the reduction, right? And so like that's a pretty digestible portion. Like that's like a very, I'm not going too far into the program to like think, okay, I'm pretty confident that that's correct. Like that seems about right. Maybe there could still be syntax errors here despite that, but that's like it's pretty. And then now what you can do is you can say, okay, in the reduction there's a few pieces, right? The infinite sequence is actually pretty easy, right? It's just one call to a lazy sequence. The the function call itself, and then this is the initial state of the reduction, and then there's now this part was what I was describing, where you can actually sort of use the structure of your code to make things easier for you, instead of trying to write this whole reducing function in this spot right here. I moved it away by just giving it a symbol, and I said, okay, I'm going to write this somewhere else and just assume that this is correct. So as far as this part of the code is concerned, we're going to just assume it's correct. Then I can say, okay, given those assumptions, this is probably correct so far. So okay, fine. Now I can take a look at this reducing function. Now this reducing function is pretty important. This is like the really, really significant part. This is like the algorithm, the meat of the algorithm. And the way a reduction works is basically you have an initial state, and you basically perform the reduction function on that initial state with one of these values from the collection as another parameter, and then iterate again with the next value in this sequence as the parameter changes to the next value in the sequence. And so there's a kind of, it's not a zip, but it's like a sort of reiterate through this initial, you reoperate on this initial state over and over again with another sequence sort of feeding in values that you can use in the reduction. In this instance, we actually don't care about the values that would get fed in, so we can just you can just use this underscore to denote that it's a variable that, yeah, we have of these numbers available, but we don't care about them. And the reason is that there's actually something intrinsic about this algorithm that's going to cause the reduction to halt. So we don't not only do we not care about those values, but we also we're not going to use them, and we don't care at all really about those values. So really this is just to construct a loop, basically, to create a kind of a loop using Clojure constructs. As for explaining in detail, I'm always eager to see the result of writing a program. Now you let me rethink how to do practice. Yeah. I mean, correct. Thanks for explaining in detail. Oh, okay, sure. Yeah, absolutely. Thank you for listening. Thank you for listening. And then obviously, right, the algorithm itself is right. We don't care about that the sequence here, and then you can use destructuring. It's called in Clojure to basically, instead of returning, because this only ever returns a single value at each step. But what we're going to do is return a vector and then destructure the vector to the parameters that we want. So that way we can use sort of a tuple throughout the reduction rather than just one argument. Because what we want to do is we want to have eventually we're going to have a vector of all of the digits that we want to return, right? All of the parsed digits, and then we also want to have the state that we're changing as it's changing when we divide by 10, right? Because we're gonna take modulo 10 to get the first digit, and then divide by 10 to move it down, and we can repeat that. And the condition on which we finish the recursion will be when the quotient is 0, right? And you got to kind of be a little careful here, and I'll explain this in a moment. But yeah. So that breaks down to something really simple, actually. I mean, getting the digits of an integer is kind of simple, in some sense, but doing it in Clojure, for me, tends to be a little more involved, I suppose. But yeah, this kind of just like lays it out like very, in sort of an easily followable way, I suppose. Followable. So right, so what we do is we say, okay, let's just define, q is going to be the quotient, divide by 10, integer division by 10, and then take the remainder. We'll just call it m. I could have called it something else, but just called it m. What we're going to return is what we got previously, and we're going to conjoin m, which is actually the digit, the rightmost digit, and then we say, okay, if the quotient is 0, which means that after dividing by 10, we got 0. Because you could actually, like, if you consider like 10, which has the digits 1, 0, when you divide by 10, you get 0. So you can't just check if you have 0 directly. You have to check if the division by 10 gives you 0. Is that right? Did I do that wrong? Let's see. If does this work on 10? Let's think about that for a moment. 10 divided by 10, the quotient gives you 0. No, I think I did this wrong, actually. Oh, no, it's okay. Oh. Is it okay? No, I did this wrong. I did this wrong. When you have 10 and you divide by 10, this m, 10 modulo 10, it's 0, right? So this will get a 0. And then, no, this will be a 1. I'm sorry. No, this will give you a 1. It's non-zero. And then I'm thinking of a case where if you just gave it 0, I think that's the edge case that this handles. Believe it or not, it's just 0. If you put in 0, then the quotient 0 divided by 10 is 0. But here we've appended the 0, and we'll still return correctly. Whereas if you don't conjoin first up here, then I don't know. It's a tricky thing. proof of correctness for this. Yeah, the algorithm itself is where really the meat of your proving things comes into play. But I think this is the correct algorithm. Just gotta think about it a little bit. But I would note, yeah, I mean, you kind of want to break it down into small pieces as you can. But this part gets kind of hard to think about. I mean, this is actually getting into sort of an inductive argument. Let me think again. Well, we could just try it, run it, see. Usually when it gets more complicated, I'll just run it a few times and kind of defer it, not really to like a formal proof, but just like, did I miss any test case? I think a formal proof is better though. Like, I don't know. I think it's better to formally prove it. Argument destructuring for function only takes the first two arguments, and when you got the 0, the previous ret should be the enough. Only takes the first two arguments. Yeah, this one will, right. So this will destructure this, and then the third argument is actually going to come from the collection. Yeah. And that's enough. Yeah, that should be enough to previous ret should be enough. Yeah. Note also we rebind this ret within the let, so we actually add a digit. So at every execution we add a digit, and then when division by 10 gives you, maybe that's the way we can know it's correct. When division by 10 gives you a 0, then you know you don't need to add any more digits, right? So then you can use reduced ret q, which all this does is terminates the loop. I think this is also the right way to do this. We'll find out in a moment if this actually works the way I think it does. If this returns this value. And finally, obviously at each instance we've already done the computation here, so we can just return the state. So actually every case we return the state, and then here we just terminate the loop. We'll see if this works. I'm curious. I don't know. I mean, I don't actually know if this is right. I think it's right, but we'll see. More likely than not, there's some. Oh, okay. So a couple things. One, it's not correct, right? True, false, false. And two, I did actually write enough, like write this in a way where it compiles. So we'll find out what's wrong. 999. We said we'll multiply these two and then take the digits. And what we want to do is actually just print this, so we see what happened. Why did it not give us what we were expecting? But yeah, your initial intuition that it's pretty hard to write all that code and sort of be confident that it's correct. Generally speaking, it is very difficult. I agree. You kind of want to test in between. So we have 198. Really? Oh, it's got to be reversed. Okay, fair enough. What we can do is we don't actually need to conjoin. We can cons m to ret, and that's better. That we don't need to reduce that. Don't need to reverse. Yeah, like this is sort of like we're talking about experience. I would have caught that if I was a more experienced Clojurian, we'll say, because obviously I missed that because I. Well, this actually should be. Well, let's see. What do we get? Let's print it again. More experienced Clojurian, I would have Clojure programmer, I would have definitely would have caught that. Realize that it's gonna push the rightmost digits to a vector Yeah, it's going to push the rightmost digit to the beginning, first the beginning of the vector, then the next digit, secondmost, rightmost, to the second position of the vector. So reading left to right, it's actually going to go backwards. So what we would want to do is actually push it to the head of a sequence each time, which is what we're going to do. Cons is dealing with sequences, and this notation is a sequence rather than a vector. And so now it's correct. And note also that this comparison doesn't seem to care between whether or not this is a vector or a sequence, right? It still returns true anyway, which is kind of weird. You don't often expect that. Yeah, so let me let's do this. Let me see here. Okay. So this is kind of a lot of code for something. Oh, no, I did it wrong. Hold on. Shift first. There we go. Kind of a lot of code for something relatively simple. Also, oh, really? You're kidding. Shucks. I can't use reduced? No. That's another thing every now and then you come into let's see, argument destructive function, get the zeros, previous route should be enough. Oh, I'm wrong? Are you wrong? Great. What were we wrong about? When you get the zero, oh, that's what you were asking. Oh, I see. Get the zero, the previous ret, should that be enough? It can be. Well, this actually, right, so this will happen before you get the zero. In other words, you may or may not get zero, but you're going to append the digit and then check if you got zero at the end. And the reason why you want to do it this way, this first, and then return that, the new sort of newly bound value. The reason you want to do that is because if you get zero, and you say 0 divided by 10, right? If you just check if it's 0 or not. I mean, you could technically just throw this inside here. It doesn't actually need to be rebound. There's a few ways to do it, but I think this is okay. This is fine. But yeah, yeah, it's happened to me in the past where, and that also somewhat from experience, because I've written this routine many times in different languages, I guess, and one of the things you can run into is if you just check if the thing you're looking at is 0, and then if it's 0, return whatever you have. The problem with that is if you start with 0, that'll give you the empty set, the empty vector. Yeah, so you want to check. You want to get the digit first, push that into your vector that you intend to return, and then if what you've got left over after getting that digit is 0, then return. Which is, yeah. Now here's a problem. Here's another problem, which is kind of fun. One thing weird to me is that the range produces an infinite sequence, but you never use the value from it. Yeah, it is kind of weird. It's definitely weird. That's unusual. I actually just learned that I could do that just today. I forgot. I mean, I knew it, but I forgot about it. Right. It's an infinite lazy sequence. Basically, what it provides for us is just a loop. It's basically like a while loop. It's a different way to write a while loop. And then the condition that'll terminate is here. But it is kind of weird to think about. Definitely weird. Lazy sequences in Clojure are kind of useful. So this is a lazy sequence. Basically, you won't operate until you need the values. Like it won't because it's a functional programming language. Things are kind of abstract. So it's not actually a sequence of all those values. It's just a sort of like a generator, I guess, if you're familiar with Python, has like generators. So it's more of an abstract notion of a sequence. And it'll give you all the values that you need as you need them, rather than the whole infinite list, which obviously, like, your computer's finite, so the whole infinite list will just crash your computer immediately or run out of resources immediately. Yeah, and what's interesting about that, right, is we don't even need to use the values because we don't care for it. We just want to operate on the. This ends up being kind of like a state machine type of thing, I guess. I don't know. I don't really even know how you explain it exactly. It's more like we're iterating through the states until a certain state is reached, something like that. Which is, I mean, technically you could rewrite this whole thing as like fixed point iterations, it's called. But yeah, that would be what it is. It would be like a fixed point iteration that stops here, and you sort of it would return the same value over and over again. I guess once you reach here, something like that. I don't know. I have been kind of conflicted about like what is or is not functional programming. Like here idiomatic functional programming, and I think using the built-ins is sort of good enough. Like I try to avoid using something like you could do a loop and recur. Like you could write a while loop like directly, but I don't like doing that as described because I don't think it's totally idiomatic to use loop, like the looping structure directly. Excuse me. You could do it that way too, but I tend to prefer not to do it that way. Yeah. Tend to avoid it. But yeah. So. Oh, now here's an interesting thing though. I mean, the reduced should be used rarely. I was thinking the most common use case for reduce iteration should be terminated by the sequence you provide. Maybe use iterator map. Yeah. I agree. I think you're right. The reduce should only be used for finite sequences. I think I agree with you. For the most part. Maybe use sequence iterator map. Well, map I don't think I can use here, but iterate maybe. The thing with iterate is, I guess I could use a take while. That might be good. Yeah, that's maybe not a bad idea. Oh yeah, that's a lot better I think. Right, because you can create a lazy sequence that provides the digits from right to left. I like that. That's much better. And you can just take while there are, digits to take. I think iterate is better. Yeah, you're right. No, that's good. That's a good call. That's a good call. I didn't think of that. Let's do that. Also, because apparently reduced is not even resolving here, which is really weird. I've noticed that it depends on like if you're doing like HackerRank problems or LeetCode problems or even Clojure problems, the various sites that you enter your code into, they won't always support all the things you wish it supports. I think if we look, we'll still find it. That reduced is, I don't know, it's in the core. Should be there. I don't know. I don't know why they don't have it. But yeah, I agree with you. I think reduced is probably not good to use too often if you can avoid it. All right, let's try to write this using iterate instead. Let's see what that would look like. Let's do it this way. Let's say next digit, something like this. All right, and we'll say given x. Now here's the question: do we want? Here's the question. No. Yeah, iterate. We can do iterate if we use two values. Yeah, we still have to maintain the state. Yeah, okay, we can still do it this way. And then we can say, we'll do exactly the same thing, I think. Not reduce though. We'll just return if, well, no, we don't even need this anymore, right? We can just say return. All right, this is going to be no, not lazy sequence. It's going to be an iteration, right? Iterate. Q return value will actually be the digit. So we don't need this anymore either. Yeah, I think iterate makes this a lot simpler as well. Think of it that way. So we want to return M, right? And then the state of after the operation will be Q. And return cons, and we don't need this anymore either. right? And then we can even say, let's do it this way. Wow, that greatly simplifies things. Yeah, where you can use iteration, I think, as much as you can, you want to. Can even put this on one line now because it's simple enough to view it, to see it. So next digit, or which we'll say next division maybe is better. Right. Sometimes naming things is like, you could spend kind of a lot of time thinking about how you want to name things, but maybe it's better to yeah, let's just do next digit. That's fine. It's not perfectly accurate, but it's you get the point, you know. I've noticed that. That's like also with writing emails. If you work in an office, like the office I work in, I write quite enough emails, and I also I parse through numerous emails day to day. I think something like over between like 100 to 200 emails a day I go through, and maybe even more than that. But mind you, I don't read all of them. I just kind of quickly check the subject line, check who it's being sent to, who it's being sent from, and just check that if there's an issue that someone's looking at it from the company. That's a lot of what I do, is just kind of make sure that things are working smoothly, that things aren't like just kind of lost in the void in the I guess in sort of like the email system. So anyway, what was I saying? I have to craft an email every now and then, and sometimes there's a certain degree of like urgency, like the email needs to be sent like very quickly because someone's going to act on the information that's in the email and potentially make money or lose money depending on how things go. So faster is always better, kind of a deal. And sometimes in those situations, sometimes that happens. And quick choice of words, so that way you can still get the point across, but not spend so much time like meandering about thinking about what to name it. It has serious impact, at least it can with the emails. But I wonder when you're writing code if there's a similar situation, because you're typically somewhat time boxed when you're writing code. Like you only have there's only finite resources, only so much time. Like you're usually under some kind of pressure, somewhat, when you're programming. So I do wonder if it's better to like spend that extra time thinking about how you want to name your whatever it is you're naming, or if you want to just kind of give it something that mostly gets the idea across, and then move on to the next piece, next thing that you're working, next sort of procedure, next thing to think about. I do wonder, because you could spend a lot of time thinking about what you're going to name something, and I think it's probably suboptimal to spend too much time. Yeah, kind of an interesting, also kind of like a meta-analysis type of thing. Something to think about. But anyway, so all right, let's iterate this way, see if this works. We'll get the quotient, we'll get this modulo, and we don't need this anymore. We'll just name it next digit as the function, and then we'll say what we want is there's going to be this take while. Right, we're going to iterate over, forget reduce now. We're going to iterate over this initial state will be empty. No, initial state will have two values. You could say quote x10 mod x10 as the initial state, right? So that way when you get the value the first time around, it gives you this first, or rather it should be the second one, right? You could iterate over this, and then you can do a take while with a call it one of these functions. And the problem with this is I would want to operate as I'm taking the value. I'd want to get the second one, extract that as I'm going, but I'm not sure that I can. You can do, this is better. This predicate, small destructor here. We'll say digit, and we'll say, I don't know, digit comes second. We'll say I don't call it X. We can call it something else. Current value is just V value, and we'll say take while V is non-zero. Could even do complement 0 or not 0, or this works too. That's all well and good, but the problem is this sequence will have, yeah, I mean we can map over this too, I guess. This also works, and you want to map with, also kind of want to use the destructuring here. You can do this, just do second. Alright, let's see what happens here. I don't know what's going to happen. This I'm kind of just jumping right into it. See how it goes. Unable to resolve prodigies in this context. Oh, okay. Let's try again. Let's try again. Wrong number of arguments to iterate. Ah, of course. And you know what we can do also is do this kind of deal. Take while, as a function, iterate, then we can just, there we go, a little better. False, false, false. Okay. So what is this next digit going to give us? If we do this, so this, I don't use iterate too often, so I'm kind of unfamiliar. It's going to be my excuse. If we just take a bunch, right? Just take like 5 of these. Wait a minute. Okay, anyway. Do this like so. What do we end up with? 0, 1, 0, 1, 0, 1, 0, 1. Interesting. 89, 0, 1, 0, 1, 0, 1. Oh, okay. Maybe this is why. Maybe this is the issue. Maybe pretty silly mistake here. to do. 0, 1, 0, 0, 0, 0, 8, 9, 8, 9, 8. Okay. Interesting. And this 1, 891, right? Okay, that looks correct. Now if we go back, let's see what we get here. False. Oof. Why do we start with a 1? My question. 989, I see that. But where does this 1 come from? There's a couple things here. A few things to consider. Can we do this way? Yeah, there's a few things to consider. So, first thing is First thing to consider is why do we always have a 1 in there? X modulo 10, for some reason this gives us a 1. In theory, this should always be the first digit, 98901. Maybe it's actually correct. What is this? Oh, okay, so there's always a 1. All right, no, that's fine. So each of these cases there is always initially a 1. The problem seems to be we need to identify when is so 198. So really the issue is we're just missing the last value, right? This is 191098. And it also looks like these need to be reversed as well. Can use a threading macro here as well. Well, yeah, we'll throw that in there later. But we need to get the last value. The problem with the last value is we don't really have a good way to terminate here. Because this, oh, I see. Yeah, this terminates early now. This is the problem I was describing before. Well, not the same problem, but this is somewhat related to the problem I was describing before, where a little bit hard to deal with. It needs something like take while when the first number in the vector is not 0 and one more item. Yeah, exactly. It seems to be terminating 1 too early. Like, how do we do this? How do we do this? We need to take 1 more, really. Yeah, we can't just take when the last digit is 0 because we may need to use that number. How can we do this? Let's think for a moment. Maybe we could use a previous value. I don't really want to do that though. In other words, we can get kind of like a look ahead here. think about this. How do we do this? Yeah, not an obvious way to do this, right? If we yeah, this is the problem we described before, where you actually want to you want to get the digit when this occurs, not stop before. Sort of want to do one more take when this is true. In what can be done is you can use this take while, right? And that'll give you a sequence. And then you can say that last state before you map, you can do one more next digit, right? Return that value, and I think cons that. Is that right? It's more like conjoin, not cons. Because this also looks like we're going sort of backwards. And then you can map and reverse. Seems like a lot of extra operations, though. Seems like this actually is not as simple as I thought it would be. I thought this would be as simple as... Excuse me. I think we should change the generating part. Maybe, yeah, maybe that's the issue. That could be it. Possibly. Just think about that. Let's see. What could we change this to? We could do, yeah. What I was suggesting was adding an extra value here, right? And you can use that to kind of figure out when to stop. The way that would work is, how would that work? You would have what? Excuse me. What can we use though? That's the question. I want to say something like Good. Yeah, maybe we could. Okay, let's try this. Let's try this. Previous, or say current. We'll say Q and X, right? And current will then be Q, and this will be maybe we can do it this way. This does not make a lot of sense. This is like the previous quotient, and then this is whatever the current quotient is, right? Split that into two pieces. I think this will work. This gives us sort of a look behind kind of a thing, but I don't think it's good, you know? Kind of conflicted about this. And then now we can say x is not equal to 0. Now even this doesn't quite work nicely either, because now if you use 0, that's not what you want. Right, 0 will give you the wrong answer here. Also, this becomes sort of, call it ABC. We'll just call it ABC because, and this is like not A equals 0, B equals C. You actually want to take the value when A is 0. I don't know, I'm just conflicted. Not sure. Not obvious how to do it. Map will be easier since you can mod quote by 10, 100, 1,000. Oh, map rather than iterate? Yeah, you can do that, although that's not really great. The problem with that, you could do it that way too, but the problem with that is if you have very large numbers, you end up dividing by 10 raised to some power, which I think is not great. That's fair. I mean, you're right, you could do it that way, but I kind of prefer not to do it that way. A reduction seems a lot better. Reduce, but the problem with iterate is yeah, the problem with iterate is the problem we run into right now, where we really want to like the problem with the map is that you just end up dividing by very large numbers, which is kind of unnecessary. You have to produce those large numbers in the first place as well. So you do kind of a lot of extra math. It's unneeded. Multiplications and divisions. How can we solve this? I think I got it. When x is 0 and dividing by x, the quotient of x is 0. No, we want the man. You could, in theory, this take while seems to be really the issue. It's not really the iteration that's the problem. The generator is okay. It's just you need to take one more extra value from the generator, from the sequence. Yeah, the sequence is fine. It's just you need to take one extra value from the sequence. I think the best thing to do is to name the sequence, and then just build the. Yeah, I'll show you what I mean. Let's do this digit sequence, right? Right, if you remember, if you recall, sequences are abstract in infinite sequences are abstract notions in Clojure, so you could do something like this, and then you can say take a while, let's go do this vd not equal v is not equal to 0 of this digit sequence. The problem with this though is you need to take one more after this. Oh no, wait a minute, you're kidding. Shucks. Oh no, I don't know if I can do that. I don't know if I even can. I think I need to reduce something. Oh no. That's challenging. I don't know, man. You could probably get a simple sequence firstly by iterating quote prod value. No, the problem with that is if you divide by 10. Oh, you know what? That's a good idea. Yeah, good call. I didn't think of that. That's a very good idea. Ah, that's clever. Yeah, that's much better. Aha. Aha. Very good idea. Good call. Forget next digit. No, you're right. Yeah, the generator. Good call. That's a good idea. All right. Let's take, yeah, let's do A times B. We'll just go right in there. Get that digit sequence. Right, because now what you can do is take modulo 10 of each of those pieces. Aha. Aha. Very, very good idea. That's a great idea. Fantastic. So now what we want to do is take while digit sequence is oh, does that work? No. Does that work? Wait. Let's try that. Hold on. If we do that, then right, we'll get, like, for instance, 981, right? We get 981, then we get 998, then we get 9, then we get 0, right? The problem is if we start with 0, I think we get a similar problem. Well, basically we want to say keep iterating until we're not 0, right? So we can just take modulo 10 each of those values. So we get 981 modulo 10 is 1, 998 modulo 10 is 8, 9 modulo 10 is 9, and then we have a 0, and we stop when we're looking at 0. But the problem with that is we want to take, I think I know what to do. We want to say we want to stop when modulo x, or let's say z, we'll call it z, or just d. When we say modulo d No, we still want that value though. Like, for instance, if we have 10, right? We get 10 and 0. 10, 1 and 0. Shucks. Quotient of D10. I'm trying to figure this out here. I'm not sure. Quotient D10. If we say that's equal to 0, so it's not equal. The problem with this though is we just take 0, right? Digit sequence of just all zeros. No, I think we hit the same problem. I think we hit the same problem. There is another way to do this, which is a little bit better. Actually, with digits, you do know how many iterations you need to go. So we could have used instead of using reduced, we could have used a simple loop, which, like, we know the range. So because digits are, like, you can count how many digits there's going to be given a number using a logarithm, right? You log base 10. I think it's log base 10 floor plus 1, I want to say. So like 100 would give you 3 digits. 101 would give you 3 digits as well. 999 gives you 3 digits also. Yeah, so floor of the logarithm base 10 of the plus 1. We could use that instead. I mean, that works as well. Yeah, you could do that too. I was kind of trying to avoid that though. Could do take while before we do map. So the sequence for map will be 98198 and 981989. No, but the problem with that is iterate, take while, map, reverse. The problem with that though is if you try 0, right? What's your take while condition going to be if it's 0? In order to actually capture the 0 digit, right? I think it's that, yeah. That may just be an edge case you have to deal with, potentially. I mean, if you assume these digits are all non-zero, then I guess you don't have to deal with that edge case. But doesn't say, right? I'm looking for a solution that can handle the 0 case correctly, that I don't need to actually add any extra code to sort of deal with that single situation, I guess. Yeah. All right. Yeah. Okay. We'll do what you suggested. We'll do exactly as you've suggested. So we'll say, okay, what this is going to look like is we don't need these anymore, really. Or this. Oh no. No. Yeah, no, I don't really need this either. Okay. So let's try this now. I think I have an idea now. First things first, let's open up the line REPL while I'm tinkering here. So what I want to say is iterate with quote %10, right? And we'll start with a times b. And then we're going to take a specific number of these, which is going to be, so we take 999, and we're going to take math log, right? And we're going to say math floor and we're going to convert that to an integer, and we're going to add 1, and we're going to use that, and we're also going to use, can we use 10? So I think it's the second log, base. Okay. We can use this now. Can use this now to be, maybe we do need a let. Maybe we should use a let. We'll call this, so we'll say T for target will be A times B. We'll say iteration, we'll say N, or we'll call it N. I'm not sure exactly what to call it, of T, right? And then we're going to say iterate over quotient of T. And then we want to say take N numbers and digits, excuse me, map as you've described, another function which is going to be modulo 10. And finally, reverse that sequence. And we can say, probably reverse. And we can use the threading macro you pointed out. Make things a little nicer. Let's use T. And then we can take N from T, can map. I like this a little bit better. Well, I mean, this does avoid using the reduced, but it kind of doesn't at the same time, because there are situations, as an example being, consider like binary search, where you don't actually know how many iterations you're going to perform. And I mean, you can get a bound on the iterations, but you don't really have an exact bound, and so it's kind of even difficult to find the bound in the first place. And you probably want to take advantage of like being somewhat unbound. Like there are even more complicated situations where you would probably want, well, I shouldn't say that. Well, let's just say there are situations where you probably want a while loop, and it's kind of, in my opinion, it's kind of hard to do that without using reduced. This is an example where if you don't use N, you probably want to use something like reduced or a loop, while loop. I mean, here we obviously know how many digits we have for a given number. So let's see how this goes. Take while positive integer. YouTube message is really slow, it's not immediately reached. Maybe the sending is immediately, but there's a lag on video stream. Oh, interesting. Can I have a function that defines log print xx, which can help log the value? on each step in a threading macro. Oh, I should do that. Oh, I didn't think of that. Thank you. Yeah, I should do that in the future. Right. Right. I have this tendency to write my threading macros and then I'll throw print statements in there. Oh, thank you. Thank you for pointing that out. I didn't. It seems really obvious, but I didn't think of that. And now that you mentioned it, it's like, oh yeah, of course you could do that. But I just, yeah, that's really useful. Yeah, thank you. I'll do that in the future. Appreciate that. So there is yeah, I don't. If I was not going to use this idea right now, obviously we could check if it's 0. I mean, you're right. We could throw something in here that uses a take while, and then we just check if the input that we get in the first place is 0, just return 0. Like we could handle that edge case. I suppose we could do it that way. I kind of dislike that, but yeah. Let's see. So okay, let's do this. Let's see what other people did. So I kind of like this solution. This is a little more compact. Actually, let's do it this way. Let's try this now. Doesn't use reduced at all. Okay, let's see the solutions other people have. Apply string sequence. Yeah, I was thinking about that. Using sort of converting it to a string. It's pretty. You could do it that way, but it's kind of like, come on, man. Resequence digits. Yeah, I don't think that's the right way to do it, in my opinion. Subtract 48. What is this, man? What is this? Come on. What? What's going on here? Yeah, it looks like everybody's just converting it to strings. Here we go. Oh yeah, he didn't even bother, this fellow. Owen Waterloo. He basically went ahead and, oh, did I map anything also? Did I do that? I did, yeah. Iterate, take map. You can actually map iterate. That works too. Starting with a 1. Oh, what's this? How did? Multiply by these, divide by this value, quotient map that. Oh, he did. Okay, yeah, he multiplied by tens. Yeah. He did the other suggestion that you made, where you can produce powers of 10, and then divide by each one. Yeah. Take while you've got. Now this doesn't make a lot of sense though either, because actually you shouldn't, in my opinion, you shouldn't even use an iteration here. You should, oh no, not an iteration. You should use if you're going to do it this way, you want to use like a zip map type of, not a zip map. No, wait a second. I'm not sure. Hold on. No, he's right. I'm sorry. No, that's fine. That works. That works out okay. I take it back. Yeah. No, that makes sense. And then just. Wait, why? I'm really confused. What's going on? So we start with the oh, that's interesting. Okay, I think I get it now. Yeah. All right. So you divide by 1, and you get the same thing again. Divide by 10, you've removed an element. Oh. So I take back what I said. What you suggested previously makes a lot of sense. Yeah, you're never going to have. Oh, I'm sorry. You're right. I take back what I said. Oh my goodness. Wow. Take back what I said. Iterating by quotient will be 981, 9890, and we only need the non-zero values. Right. That makes sense. Yeah, I understand now. Oh, absolutely correct. Wow. I should have listened. It does handle that case. I was wrong. Yeah, you're right. You only need the things that are positive. Fair enough. Let me try that now. So we'll say we want to iterate, and we'll do quotient 10, and we can do A, B as right the starting point here, and then we can take while positive int or non-zero. Yeah. Is there positive int? Is that a thing in Clojure? Find out now. Yeah. Take while as a positive integer. Map revert. I think this one works as well. That's great. Oh. Okay, I don't have a positive integer here. It's fine. We can use. Yeah, just greater than 0 should be okay. Cool. That's awesome. Heck yeah. Nice. Very nice. Well done. All right. Well, that is much more concise. I like that a lot better. Very good. Thank you. Thanks for bearing my bad English. Today's a good day for me to watch your stream. As you can see, my English is not good. I'm searching somewhere to learn how to communicate English. Oh, I see. Oh, there you go. Yeah, that's good. That's very good. Yeah, feel free to use my stream for that. Not bad. Also, I see. Right, you're a Clojure programmer, which is pretty cool too. So I nice. Well, that's much better. That is much better. I think the next thing to consider would be okay. Let me actually. So I'm gonna end the stream, go get food, come back. Pretty nifty solution though. I'm gonna remember this for the future. It's very good because this comes up every now and then. Getting the digits of a string, or not a string, but getting the digits of an integer. And I like this approach. Definitely like this approach. It's very concise, clear, simple. Does this work if we use 0 though? I keep thinking it doesn't work. It does work though, right? should work. Why do I think it doesn't work? False. Oh, it doesn't work. Oh, I'm sorry. No, it's assuming it's a positive integer in the first place. Shucks. Yeah, no, I was right. I was right initially. Wait a minute. Man. It's pretty funny. Oh no. Alright, go back to the original solution. Not the original, but the one I had previously. Okay. Does this work on this will work on zeros. Oh. No, the 0 times 0 should be empty. No, that's not true though, right? Because oh, whoa, negative infinity. Oh, wait, what? Oh, can't take the logarithm of 0, can you? About that. About that. Whoops. Ooh. Could just say throw an if statement in there. So if 0 t could just return 0. Right? Still wrong here. Still wrong. Yeah, alright. I mean, I think it's like no way around it. I have to deal with that edge case differently if you're shucks. I think it should have a digit in there, because if you're saying how many digits does 0 have, it's one digit, which is 0. I don't think it should be empty, in my opinion. But yeah, both cases you would need, both approaches you would need some if statement in there. Shucks. The only one that doesn't require that if statement is the that reduced version, but that reduced version is still like you have an if statement built into it anyway, so it's not really. All right. Anyway, we don't have to spend so much time on this problem, but yeah, there's not really like a super concise approach that deals with the 0 case. I mean, this is pretty good. The variant that we had is pretty good, but it doesn't. The other approach is what these guys were doing, which is string to sequence, which I think is actually not too bad overall. Make a string out of it and convert it to a character map. It might actually be faster to create the character map. Nice, look at this. Comments. That's a lot of comments, man. It's great. Okay, let me, yes. Oh, I see what the subtracting 48's the character map as well. Let me, go ahead and end stream here, and we'll come back to this. We'll come back. Makes sense. Just open 4Clojure to see this problem. Oh, you did, okay. Yeah, 4Clojure is pretty good. I'm also, yeah, I'm impressed that you know Clojure. Not that many people know Clojure. It's pretty niche kind of a thing. All right, least common multiple. Write a function which calculates the least common multiple. Your function should accept the variable number of positive integers or ratios. Interesting. Least common multiple. Oh, that's interesting. Least common multiple. Wow. We'll come back to this one. The least common multiple. Oh, that's least common multiple is related to the GCD. Actually, the GCD times the LCM is equal to the product of the values, so you can just use a GCD function. And the interesting thing about the GCD is a oh, but this also has rational numbers involved. I don't know how to do GCDs of rational numbers. Just don't know it. But you can use there's transrecursitivity, we'll call it transrecursitivity of it's transitive. It's recursively transitive. GCD, meaning the GCD of A, B, and C is equal to GCD of A and B, and then the GCD of that result with C, which is kind of interesting, kind of neat. It's like, I guess, associative, something like that. Not really associative. It's just, yeah, we call it quote unquote recursive transitivity, recursively transitive. Let me end the stream though. I don't really have an idea of how to solve this, but I'll think about it on my way back after I get food. So yeah, I'll be back. Thank you again for watching, and talk to you soon. Great stream. Time for me to sleep. Have a good day. All right. Have a good night. Talk to you soon. Take care.